We've seen that Iceberg splits files into two layers. The data layer that holds your actual records in Parquet or Orc or Avro or whatever. Then the metadata layer, that's the manifests, the manifest lists, and the metadata files that track what's in the data and where the data is. So you want to query that sales table. How does Spark or Trino or Dremio or whatever know where to find the metadata file? You're not going to hard code that S3 path into every query. That would be ridiculous and painful, and nobody wants that life. And anyway, it changes with every single snapshot. No, you're just going to write select star from sales. Hopefully you're not literally going to write select star from sales against your data lake, but you know what I mean. This is where the catalog comes in. It maintains a simple mapping, table name to metadata file location in your blob store. Here's what happens. The query engine says, hey, catalog, where's sales? The catalog says, oh, the metadata file is S3:/ blah, 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 /something / blah, blah, blah. The engine reads the metadata, follows the tree down through the manifest list and manifests and the actual data files, and there you go. Every commit, whether it's new data, schema change, partition update, whatever, the catalog gets atomically updated to point to the latest metadata file. Keeping a pointer to the current metadata file for each table is the first responsibility of the catalog. New data means new metadata file, which means a new pointer. But that seems a little too simple. That's not all the catalog is willing to do for us. It also ensures atomicity. When that pointer swaps from old to new, it's one atomic operation. This is what gives you consistent reads and safe concurrent writes. If two writers try to commit at once, only one of them wins. The other sees the conflict and retries with the latest state. Third, and this is important, the catalog coordinates. It doesn't write anything. It doesn't write data files, doesn't write manifests, manifest lists, metadata files. Your engine does that, Spark, Flink, whatever it is you're using. The catalog just tracks which version is current and makes sure commits don't step on each other. You might be wondering, is there a standard way for catalogs to work, like a common API? Good news, there is. It's called the Iceberg REST catalog specification. It is just a spec. It is not itself an executable thing. Iceberg provides a reference implementation, of course, but it's a spec and anyone can implement it. The main open source implementations are Apache Polaris, Unity Catalog, Apache Lakekeeper, and Apache Gravitino. Let it never be said that Apache doesn't care about your catalog needs. Some of them really stick to the basics. Track tables, point to the metadata, get out of the way. Others implement the full spec and add governance features on top, like access control, lineage, that kind of stuff. The spec also gives you portability. You can switch catalog implementations without changing your table format or rewriting queries or rewriting any data or anything like that. Of course, if one catalog provides a feature that you really like, you're going to stick with that catalog, but the underlying mass of the data lake is compatible between them. Here's another trend, multi-format catalogs. Right now, you probably have separate catalogs, one for Iceberg tables, one for Delta, maybe another for raw Parquet files. That's a pain. The new generation of catalogs handles all of it. And catalogs are adding more advanced features. Some are implementing Git-like versioning for metadata, so you can branch and merge table schemas like they were code. Some are adding cross-region replication, real-time metadata sync, even automatic table maintenance to keep files compacted and snapshots pruned. Catalogs are evolving from simple name to location mappers into kind of little control planes for your entire data lake, a portion of your whole data platform. If you're a Confluent Cloud user and you're using Tableflow, which we're going to cover in this course, Tableflow itself provides a fully compliant Iceberg REST catalog, and it works on all of the clouds. If you prefer to stick with your own service provider, each one has their own product. There's AWS Glue, Microsoft Purview, Google Dataplex. Now, they can work along with Iceberg, but none of them fully implements the REST catalog API as of the time of this recording. Now, if you already have data infrastructure of some kind, and well, who doesn't, Iceberg can work with that too. Hive Metastore, JDBC databases, even Hadoop, they can all act as Iceberg catalogs. They weren't built for Iceberg, so you might lose some features, but you could get an integration win. Hive Metastore, for example, doesn't support atomic commits with multiple concurrent writers, again, as of the time of this recording in late 2025. It's okay for batch ETL type things, but streaming, you're probably gonna have some struggles. In any case, catalogs aren't optional. That's a necessary part of what it means to be Iceberg. Every Iceberg data lake needs one. The good news is you have the options. REST catalogs for flexibility, cloud native ones for convenience if you're all in on your provider, Hive Metastore if you're already still running Hive, and pick based on what you need. If you need concurrent writers, well, then you're gonna need atomic commits. Multi-region, you're gonna need replication support. It's the same thing as always. You need to look at the feature matrix, current as of the moment you're making the decision, evaluate what you need and make trade-offs from there. The catalog you choose, though, shapes what's possible, so it is an important decision. Next up, we've got ACID transactions, how Iceberg handles multiple writers without the whole world blowing up.